Hey there, it's Dr. Barton. This is a follow-up video to a previous one I did where I showed just a real basic proof of concept for the project I'm working on at the time I'm recording this. I have since done a little bit of upscaling, a little bit of exploring, trying things, and I've got a proof of concept that's a little closer to the final version. So I just wanted to document this, show it off, see what we've got going there. So let's just real quick highlight my cursor so we can see what's going on, and I'll break down the code. So all of this code on the screen is incredibly unoptimized. I'm very, very aware of that. It bothers me looking at it. I usually save making the code pretty after the code is fully functional. So it is getting better. I am aware that some things are not ideal, but you know, it works. That's the point we're at now. So what I'm going to do is just go through the code, show a brief little demo of the hardware on the second camera, and yeah, we'll do that. So right here, this is the code running on the Arduino, and the big difference from last version to this version is I basically just upscaled it to have 5 different pins that we're using for the switches and 5 different LEDs to accompany that. So I was just saying, hey, use these pins for those things. And then these are just maintaining the same variables as before, but now instead of just one, there's one for each pin, because each of the pins are functioning independently from the other. So in the final version, that part may still stay the same. We'll see. But this down here in the loop is definitely going to be condensed down and made a lot more optimal. So I'm just saying what pins are inputs and outputs and starting that serial communication right there. As we go into the loop, the process is going to be the same. It's just repeated effectively 5 times. So again, I'm going to abstract that out a little bit into some more functions, make it a little more modular, a little more, it hurts my brain and makes me less sad. But what's going to happen is for every loop, we're going to read the pins there and just get the value. Is the pin open, or is the switch open or closed? When the switch is closed, that's when we want something to happen. So once we've read all 5 of those pins, we're then going to, for each pin, do one of 2 things. The first one is, let's say if the switch is closed, that means we want something to happen. So we're going to say, hey, set the LED state to on, and then we're going to just turn on that LED. That's the first part right there. That could probably be done without some variables, but either way, I'm thinking as I'm saying stuff. After that, we're then going to send the relevant data through the serial port there. So we're just going to say what pin we're looking at and its value. That's all we're sending right there. And then last but not least, we've got this swap state here. I don't know if we'll actually need that in the final version. Originally, it was meant so it would only send data whenever the state changed. But now I'm thinking that because I've pulled out some of these checks for swap, I just don't think that they're needed. They're still in there right now, but yeah, I don't think that line is needed. So I'll probably go out shortly after I finish recording this. So we're going to send the data. There we go. If the switch is open and we don't want anything to happen, all we're going to do is say, hey, turn that LED off. Just make sure that it's off there. And then we're going to send that same information, being what pin it is and is it closed. So yeah, because that's sending every time, we don't need to send that there. So I'll play around with that. I'll see how things work. I may update it so it still only sends the first on-off message, but right now that's a bit of redundant code from the last version. But then this repeats for all 5 pins, and that's all it's doing right there. And in fact, if I open up the serial monitor, we can see it happening right here. Spoiler alert for what's happening later. Some stuff is just kind of playing all of a sudden in the background, but I've got it set up here so it's the switches are connected to pins 3, 4, 5, 6, and 7. 3, 4, 5, 6, 7. Yep, 5 pins. And then there's those zeros right after it. That 0 will change to a 1 whenever that data changes. So if I just hold my little magnet over pin number or switch number 1, just connected to pin 3, you should see that that will change to a 1. There we are. I had to get the magnetic fields lined up, and now that's a 1. I pull it away, it goes down to 0. I do it on, I don't know, 5. Now the 5 is a 1. I get rid of it. 5 goes to a 0. So that's all that the Arduino code is doing. So no, I don't want to do that. So we're just going to make sure that gets saved. And now we're going to look at the max code right here. So I have it just tidied up just a little bit visually. So that way when I interact with it, I'm, can go a little easier. But let's look at the actual what it is. Again, I'm very aware this is not very pretty. It's not great. Again, that's usually the last thing I do after making it functional, is making it look nice, and we just aren't quite there yet. So all we do is we say, hey, turn on, look at the serial data. It's gonna every 100 milliseconds send the value through this big series of data. So all we're doing is saying, hey, look for a carriage return. That's what this is saying. This data all gets sent as ASCII values, so it's all represented as a number. And at the very end of the loop, I have this serial.println, which just is, have a carriage return. So that's what's making a new line whenever we looked at the serial monitor there. So that's up in there. Then we're going to group all of that data together. So every time there's a carriage return, it's going to basically end the group there. So we'll group all the data, carriage return, send it off. I picked 1,000 there, partly because that's used in a lot of things with Max, just because that's bigger than most things you'll need. So all your data gets set up there. We then convert some of these, to ASCII, and then from those symbols just to get usable numbers that we can work with here. And then from there, we would have, if we just kind of follow over here, that same list of values from before. And if I do that, we see that 1 changes after the 3 in real time. And I'll show the board in just a second and how that's working there in a little bit. So all I do is I break those into pairs for each of the pins. So that way we instead get a list of data for each pin. So if I hover over here, you'll see pin number 3 is currently off. Turn it to on. 3, 1, 0. It's just for each pin. And then I break that further down just to say, okay, now send stuff out to the specific things for each pin. So all these are doing, the first 4 pins are exactly the same. Each one is used to just ramp up and down the volume of these audio files. And this is just a little thing I threw together before I started coding. Just a few different stems and loops just kind of overlapped it. Kind of works. It's not my favorite thing. It's extremely funky and active. I don't know what that sound was, but I'm going to play the actual sound here just so you can hear it. And that's the whole loop. It's like 8 seconds long from there. So again, whenever that magnet gets activated, it will ramp up the volume from nothing all the way to full, or whatever I decide to set it to here on these faders, over 1 second. And when I pull the magnet away, it will fade it out. So each of these stems are just playing in sync with each other, just over and over again. So that way they all kind of loop up. So if I had multiple magnets, I could trigger multiple files at the same time and build it into this kind of full version that's right here. Pin number 7, this last one, is a little bit different in the sense I have it hooked up to this toggle right here. So when it's on, it will function just like the other 4 here, and it will play just the weird effect sounds that are part of that mix. So if I were to just do that right now. So it's all the weird effects, kind of noises. Is good. I'll just pull that away there. That's totally fine. If I turn off this toggle, that's the word I want to use, then it will instead send the data through what I had before. So now the other four switches are going to function the same way, but now this final one on my breadboard, if I turn it on,
Is that...
I'm going to turn that off there. Just because that's kind of loud right now. But same idea is whenever it triggers a 1, it will play back a random file. I've got some other data in here, these change objects. Because we're polling this every 100 milliseconds, this just only does stuff when those values change, which is why I've kind of changed some of the stuff happening here. And then yeah, that's really all that it's doing. All this stuff is the same as before. It just picks a random file from here, or everything will play the stems. So with that being said, let's go over to the other camera. I'm going to make this pretty again. Move it over so that way we've got plenty of room to see everything. And let's look at the camera here. So here is the setup. It is just like before, but just a little bit bigger. So we've got now 5 LEDs and 5 switches right here. And then they're all just going to the Arduino. It's a big old mess of cables and everything. But we'll see that whenever I hold my little magnet next to the switches there, it will turn on the switch and play the sound. So here we go. And then it fades out. I go to the next one. Number 3. 4. And 5. So just at the time that I'm filming this, I only have the one magnet, but if I had multiple, again, I could trigger all of those as we go. I've realized as I've done this that the orientation is going to be important, just so that way the magnetic fields are in line, because some of these I have to like get right up in just the right position, and others they just kind of they just kind of work where I want them to, as opposed to having to like this green one I have to like basically touch it for the switch, and then it still kind of works, kind of doesn't. It just depends on the orientation of those magnetic fields. So that's happening there. So again, it's just going positive voltage through the switch. And then remember, we have a pull down resistor of 10 kilo ohms, 10,000 ohms. And this just goes right to the Arduino where we're looking at those specific pins from before. The LEDs, it just gets power from the Arduino, runs through the LED, 200 ohm resistor to ground. That's all it is, fairly simple. So that's kind of the end of this version of it, at least. I'm excited to see where we go next, and soon things will start having hardware integrated into stuff. Start maybe doing some soldering, making things a little more permanent outside of the breadboard. But the next step will be to start adding in the multiplexers, so that way I can get I'll probably scale this up from 5 to 8 different sensors all at once using that multiplexer. I might have enough just to do the full 16 again. We'll see. I am going to be pulling out the LEDs eventually, just because I don't think that's super necessary for the final version of this. We don't need a visual feedback, especially for 64 different switches all at once. The feedback will be in the audio, but for debugging and testing stuff, it's super, super handy. So that's all I've got now. Like I said, I'm excited to see where it goes. I'll see you next time I see you. Bye.